Hello there. Today we are going to look at limit of a function. So for the limit of a function, before we start, we have to look at some rules that govern it, okay? But this is the full spelling of limits. But when you are writing it, you write it as lim. Is that okay? But you don't pronounce it as lim, but rather limits. Is that okay? So the limit of k as x approaches a means that this x is approaching a. The simple thing that we are doing here is that we are just doing substitution. Is that okay? But if you look at this, here is k, here is x. Means that the x and this k has nothing in common. Means that this k is constant. So when you get the limit and the thing there is constant, or the number there is constant, it's not a variable, then, or the variable here and the one here are not the same, then you consider this as constant. Then if you have something like that, then we can describe this as constant. So when you have a limit like this, the answer is the same constant. So example is like if I have two like limits as x approaches 3. So the limit of 4 as x approaches 3, the answer is still 4 because this 4 here is constant. So the limit of a constant is a constant of the limit. Is that okay? So you should take note of that. Now you move to the down one. The limit of x to the power n as x approaches a. You realize that here is x. And so wherever we see x, you are saying that you should replace it by what? A. Is that okay? So that's why I have here. So wherever I see x, I put a there. So that will be a to the power n. Is that okay? So what you are trying to say here is that if I have a limit as x approaches, let's say 2 of x to the power 3, it means that wherever I see x, I should put 2 there. So it's going to be 2 to the power 3, and the answer is what? 8. Is that okay? Very good. So once you know this, you move on. So the limit of f of x plus or minus g of x will give us, as x approaches a, will give us the limit. So you apply the limit on this function alone, separately, plus or minus on this function alone. Is that okay? Good. Then we also have the limit as x approaches a of k times g of x. Now this k is a constant. So if you want to do it, you will factorize the constant at the back of the limit. Then you apply the limit on the function. Is that okay? If the function is a fraction like this, you apply the limits at the numerator and you apply it at the denominator. So that is how we solve the limit. So I'm going to solve examples with you. Is that okay? Thank you. Alright, so now let's look at the example. You have to find the limits of 1 plus x squared as x approaches what? 4. Is that okay? So for you to do this, what you are saying is that first, if you want to solve it, because there is plus separating 1 and that of x squared, you apply the limit separately. You are going to have the limits. Let me repeat the question. 1 plus x squared as x approaching 4. So you are going to have the limits as x approaches 4 of this one alone, plus the limits as x approaches 4 of the x squared. Is that okay? Now we said that when you apply a limit on a constant, your answer will be the same constant. So here it will be 1 plus here. The meaning of this is that wherever I see x, I should put what? 4 there. So I'm going to have 4 squared. So I'm going to have 1 plus 16, which will give us 17. Is that okay? Yes. So that's how we evaluate or simplify limits. Now let's look at another example. Example 2. We should find the limits of x minus 1 over x squared plus x minus 2, where x is approaching what? 2. Means that wherever you see x, you should put 2 there. Now here, if you want to solve it, you apply the law. So we are saying that when you have a fraction like this, you apply the limit on the numerator, then the limit on the denominator. So you are going to have the limits as x approaches 2 of x minus 1 all divided by the limits as x approaches 2 of x squared plus x minus 2. After this, now you're going to apply the limit on them separately. So you're going to have the limits as x approaches 2 of this x minus the limits as x approaches 2 of 1. You see, because of the minus, it is here. Then all divided by this place, you're going to have the limits as x approaches 2 of x squared plus the limits as x approaches 2 of x minus the limits as x approaches 2 of 2. Is that okay? Now in this case, here means that wherever I see x, I should put 2 there. So this side is going to be 2 minus, now there is a constant, limit of a constant will still give you the same thing. So 1 all divided by, I should put 2 here so that I'll get 2 squared. Plus, put 2 here. The x I was replaced by 2. Minus, here is constant, so I will maintain my constant. 2 minus 1 is 1. 2 minus 2 is 0. 2 squared will give you what? 4. Is that okay? Yes. So now let's look at the next example. So now let's look at the example or the last example here. You can also look for more and try it. Okay. So the example is saying that you should evaluate the limit as x approaches 3 of x plus 1 all divided by x plus 5 all divided by x plus 1. So the same procedure, you're going to have the limit as x approaches 3 of x plus 5 all divided by the limits as x approaches 3 of x plus 1. Then you have the limits as x approaches 3 of x plus the limits as x approaches 3 of 5. And remember, all this is going to be divided by the limit as x approaches 3 of x plus the limits as x approaches 3 of 1. Now here, the limit as x approaches 3 of x will be 3 plus, this is constant, so it will remain, all divided by, this one will be 3. This is constant, so it will be remaining. So 3 plus 5 is 8 over 4, which will give you what? 2. Thank you very much. Now you move to the next topic. Okay.